welcome to my channel. So for today in this video we are going to look into what is churn analysis, or rather what is churn prediction. I would be giving you a walkthrough on churn prediction in a telecom dataset. Now first thing is, what is churn? Customer churn, or which is sometimes otherwise known as customer attrition, refers to the loss of customers or subscribers for any reason at all. For example, for Amazon Prime, if you see, we have subscriptions for Amazon Primes, right? So a customer churn is nothing but people unsubscribing the premium subscription, thereby resulting to the loss of customers for Amazon. So that is the layman terms of what is customer churn. Customer churn can come in different formats. The one example that I provided earlier was one of the form of customer churn, but there are several formats. For example, first is cancellation of subscription. The second is moving to a competitor. It's basically like if you are in a telecom industry using Airtel and you move to Jio, for example. So that's a loss of customer wherein they lose the customer to a competitor. The third is not renewing the subscription. So there are some customers already using the subscription, but then for a later period of time they are not renewing it. So that is also considered to be customer churn. The fourth is closing the account. So this is the ultimate churn, wherein the customer is for several reasons would have decided to not go forward as a member to a particular service, and would rather prefer to close the account. So that is another form of customer churn. Let us see why you have to analyze customer churn, and why organizations, or plenty of organization or team, give lot of importance to customer churn analysis. The first and foremost point is churn leads to increase in customer acquisition cost, which is nothing but the total cost of sales and marketing required to acquire a customer. Acquiring new customers are considerably more expensive than maintaining an existing customer relationship. Thereby, the more customers churn, more amount of money you need to spend to recoup the loss of business by finding new customers. So that's the main criteria why customer churn analysis is very important. The second is reduced revenue. So reduced revenue is not rocket science, guys. Only when there is a business, the organization or a team gets money. So when an organization loses customer, or if the customer leaves an organization, and for several reasons, there is definitely loss of money, thereby causing to reduce revenue. So these are the two main things why customer analysis is very important for an organization or a company or a team. Let me walk through our customer prediction model using telecom dataset found in Kaggle website.
Been created, and in this you can see that the dataset is all about telecom churn dataset, and where we will be looking into how in terms of the customer activity data, and also how you can identify which labels help in finding out how the churn is happening and what can be done out of it. So here the test data is separated into two. There are two test data, that is a train and test, which is split in by 80-20 ratio. So let us use the larger data set, that is churn 80, for training and cross validation purpose, and the smaller data set for final testing and model performance evaluation. So let's get started. So here you can see in the first cell I have written all the libraries that are needed for this particular project, and we need to have NumPy, Pandas, Matplotlib, Math in order to do some mathematical operations, and we have Seaborn, which is a very addition library, as well as Plotly, and I've also included warnings so that it's been ignored. The warnings are ignored. So these are the things that need to be considered in the start of any project. And the second thing is, first you have the next very important thing is to read the data set. So read the two data set, which is we have the train data and the test data. So I have read the churn 80, which is the train data set as telecom, and the test data set, which is the telecom test. So after reading the CSV files, you can print the data frame or the file to see if they are read in the proper format. So you can see that there is a data set printed here using the code telecom.head. So this gives us the idea of whether the data is actually been retrieved or read. The next thing is to look into the overall training data set or the test data set. So I've written a function here to understand the number of rows, number of features, and also to identify if there are missing values and unique values. So you can see at the bottom that we have the result of the function, which is the overall overview of the training data set, which is the number of rows is uh, 2666, number of features to use, missing values 0. And you can see we have also the list of unique values along with the features. So this is for the training data set, and similarly we can do for the test data set to understand the uh, data set. So here the overall overview of the test data set rows are around 667, number of features 20, and the list of features are also printed. Missing values is 0, unique values provided as per the features. Now let's get started with the exploratory data analysis. Exploratory data analysis, we have to start plotting each variable, each features to understand how they are in the data. So the first thing I did is to plot a pie chart in identity to understand how many data, how much of the data is churn and how much of them is not churn. Below chart, this chart shows that around 85.4% are churn and 14.6 are not churn. So here you can see the red shows the churn and green shows the not churn. This ideally, if people who use this and already are an experienced professional, you will notice that this balanced data set. So we will be working on in order to fix this data. This thing is to always visualize different variables according to each other. So here we have to always make use of the pair plot function, which is coming from the C. We can use Cborn for visualizing, and here if you can see we have used the diagonal kind is the density. In this pair plot you can only find the correlation between the numerical variables rather than the categorical variables. So here you can see that we identified several numerical variables are very correlated. We specific total day minutes and total day charge are correlated. Total evening minutes and total evening charge are correlated. Total night minutes and total night charge are correlated. And lastly, total international minutes and international charge are also correlated. So this is how you identify what are the two features are multi-correlated, and only keep those relevant features so that they do not affect the algorithm or the model to predict the right output. In addition to pair plot, you can also plot a histogram to see how the distribution is in terms of churn, not churn. So here we can see that there are several numerical plots which has been plotted in histogram format, and we can see that most of the churn, a significant difference between a churn and not churn, and all of them are under a normal distribution. So for example, it shows that customer calling once and twice are churning a lot. So this is a huge difference here, guys. And the next thing is very important is the data pre-processing. So data pre-processing is basically a test step where you will have to completely change certain features in order to support your algorithm to make the proper or correct, accurate prediction. In this plot, we will be removing certain correlated columns and unnecessary column that we have already mentioned. Here you can see state and area wise code, total day charge, total evening charge, total night and total international charge are removed, and also we'll have to remove the from the column from the telecom data and have it aside, so that that's how you will use the data for your model building. And the number of levels for each categorical feature is assigned to be 6. Now let us separate the categorical and the numerical columns. So basically model building, machine learning models do not accept any categorical variable into their algorithm. So in order to do that, we'll have to convert them into a numerical format. So in order to convert them into a numerical format, you'll have to use several encoding methods like label encoding or one-hot encoding. So this is where you have to start making changes, and this comes basically predominantly in the data pre-processing. So here we are converting the categorical columns in terms of label encoding, and if you can see in the label encoding code, we are using get dummies, which is to duplicate columns for multi-values columns, and this is how you basically write the code, guys, and that predominantly get the all the categorical variable into a numeric. Second step is to standardize the numerical value. Now that you have numerical values, you need to standardize them. It will not be in a proper range. So here we have to maintain a normal distribution whenever you are inputting this data for a prediction modeling. So the very first thing is to encoding the categorical variable. The next step is to standardize the numerical variable using several methods, and we have standard scalar, we have min max scalar. So for this purpose I've used standard scalar. So here you can see I have the training test data and the train data, and I've used standard scalar to scale. So you can see that I've used fit transform using numerical column. Then for the same thing I've done for the test data set also. Summary, you can summarize your data set to identify what are the features, the count, mean, min, max, standard deviation, 25, 50, 75% of summary. And this can be done in a format. So I have built this whole function in terms of tabular format so that it's easy for us to understand and read the summary. So here you can see this is a training data summary. You can see that the features counts are given, mean are given, standard deviation, mean, 25% quartile, 50% quartile, 70% quartile, and the max values each features. So let us find the correlation for the complete data set. Now data set, you have all the data set in place, including the categorical variable converted into numerical. We can identify what are the correlations now with in terms of complete features. And here we have used the Poisson correlation coefficients for identifying the correlation, and in a format of a heat map. So this is basically a heat map, guys. So if you see the lightest value, lightest color in the chart, it means that they are positively correlated. So the diagonal ones are the correlation between itself. So international plan been plotted against each other, so that's why it's yellow. You can see number of voicemail is very high correlated with voicemail plan. So this is very important, guys. So if you identify certain highly correlated features, you include only one of them for the model. So similarly, the least features are the darkest one. So that these are the least features in the sense correlated. So we need to keep them as well to make sure that they are included in the model, because they have a nature in identifying whether the model, whether certain customers are churning or not. And finally, we have the model building, guys. So this is where you try to run the whole data set as an input, provide to your model. There are several models here: logistic regression, linear regression. Since this is a categorical prediction, we'll basically use stake decision tree. We can use random forest. We can use XGBoost. So let us look in further to what the build models have been used. In this, I have developed a machine. I have developed a function where you can use this for several models, so that you don't have to write the code for one for multiple times. So here, the first we can see we fit it. Fit is nothing but you are fitting the model with training, test, and then you have the prediction algorithm, predict function for testing using the testing data. And then we have the algorithm ready, print the algorithm name, we have the classification report, we have the accuracy scores. And also I'm printing out the confusion matrix and all the curve plots. And similarly, you can see and the confusion plot, the confusion matrix, the ROC curve, so that visualizing, if you visualize all these numbers in a chart format, it is easy for us to understand. Then we have the coefficient features. This is a similar plot that you can find in the behind. The final thing is I have also printed out the receiver operating characteristic, the feature importance, all of it as a subplot. So let's look into what is the first model that I've used. So the first model is the baseline model. So before that, we have to split the data set into X and Y, guys. So that's the train test split. And the train test split is by 80 to 20%. So you will have to split accordingly, and the random state is mentioned here so that we can make sure that our data is randomly sampled. And this is the final values that you'll have to use for the function in terms of model building, guys. The first baseline model is the logistic regression. So I have called upon this function here with all the necessary values like logit, xtrain, xtest, y, and the test, and the coefficient. And now you can see what are the values. So we have the algorithm is logistic regression. We have the classification plot, which seems to be good because we have of 0.82% and area under the curve 55%. Visualization, guys. So you have the confusion matrix, you have the receiver operating characteristic, and the features that are very uh, highly important in terms of identifying whether customer churn or not. This is the baseline model, guys. So why we have a baseline model is a model to compare on the other models whether the other models are doing better. So that's why we always have a baseline model. And the second thing is, in earlier of the video, you would have also noticed that I mentioned that the data set is imbalanced because you have around 85% of churn more data, and then you have only 14% or 15% of not churn data. So this is basically example of an imbalanced data set. So in order to make it proper, we have a function called small technique. We have a technique called a small technique, which is basically a synthetic minority oversampling technique. So here we use the small imbalance from the imbalanced oversampling for library, and we are now editing the smart in terms of editing the training data and fitting it across using the smart function and sampling it and oversampling the minority class. So we are oversampling this 15% of notch-on data so as to have for a balanced data set. So now we are using again the logistic regression here, but over the balanced data set, and let us see if our accuracy is improving. So our accuracy is basically has gone down, and the model that I've used is the usage of decision tree. Now for decision tree, we definitely we can use decision tree for base. This we have versus, but this we have used for the predicting a categorical prediction. So decision tree is a very is a widely used algorithm. If you see here in decision tree, you'll have to you'll have to give certain values, that is a max depth, how many depth or how many layers the you expect the tree can split across itself. So we are specifying it as 9. We are giving the splitter to be the best splitter and the criterion to be Gini. And let me know in the comment section, guys, if you want to understand all these terminologies in a separate video, so that I can make a video separately for that. And here if you can see, the algorithm uses decision tree, the classification report is given, and the accuracy score is 90%, which is really very good compared to the logistic regressions 82.4%. And the model, you can see the ROC curve is also good, which is 79%, which gives a proper bend here. The higher the bend, the better the model is actually. So that is why we seems like the decision tree is really good, guys. Second thing is the random forest classifier. The similar random forest classifier is a group of decision tree together. So it's a ideally it's basically a collection of group of trees forms a forest, right? So that is how we are presenting random forest. So in random forest, similarly, we have the n estimators, we have the random state mentioned, and also the max depth mentioned. So in this, you can see the accuracy score is around 91%, which is which is definitely an improvement from decision tree. And the although the area under the curve has little bit dropped, you can see it is 77%. 77 is better, bit less with the decision tree. And the feature importance has been changed, guys. Now you can see the feature important here is the total day minutes is highly important here with terms of efficiency. And earlier it's also similar to the decision tree was also similar here, but compared to the logistic regression. So that's why I've plotted a feature importance to identify which features are important in terms of different models that we are using. So let's have a correlative model report. Now model report, I have developed a function to identify what are the different models in a tabular format. So we'll have the model name, we'll have the accuracy, ROC curve, and the explain, which I will explain later in the following days. So now you can see this is the final plots that I've used. You have the logistic baseline, you have the logistic smart technique used to balance the imbalanced data, and then we have the decision tree or model, we have the random. So in these we can see the random forest providing around 91% accuracy with an ROC curve of 77, and the kappa metrics to be 64, which is high. And So the least significant feature termed to be the voice plan, and the random forest has, since in the random forest you can see the feature that plays a major role in our total day minutes, number of customer service calls, and international plans. So this is how you basically build a model in order to identify a prediction algorithm. And to further scope, you can analyze in terms of more in terms of depicting whether which contributes to the customer or churn, the customers that churns, and also can also apply several other models, guys, and basically take a trade-off between the precision score and recall score, because accuracy is not the only metric that you'll have to use in terms of identifying which algorithm performs better. You have the precision and recall, which is specified here. Precision, you have the precision recall here, 0.91, 0.56, 0.99, 0.92. So these are all the scores that you need to take into consideration to identify which algorithm did better and perform better to identify the customers that churn or not. So there are future scope, guys, to this data, but this is how you basically build a model, machine learning model, to predict.
That is all, guys, for the walkthrough. So in the end you would have noticed that we can let there are several other things yet to be explored, and in terms of data analytics or data science team, you will need to talk to different teams to understand what are the other features that can be incorporated for further analysis. So that is all, guys. I hope this video was useful for everyone. If you feel this video was useful in any manner, please do like, share and subscribe. It would be a great help for me, and at the same time please do share it to others so that it will be useful for them as well. I hope you all have a great day ahead. Bye bye.